Solving quadratic equations by completing the square. Let's look at example 24 on page 144. A is given as x squared equals 16, B is given as x squared equals 5, and C is given as x minus 5 in brackets squared equals 3. You should now recognize that your left-hand side, where x is included, is a square. So to solve that, we are just simply going to use the opposite operation of a square, which is the square root. Okay? So we're going to use the principle of Goro is o, where the opposite operation of a square is the square root. But now, importantly, as I told you already in mathematics, we must always be fair. And in this case means if you take the square root on the left-hand side, you must also take the square root on the right-hand side. And when we take the square root, people, we always have either a plus or a minus. So if we take the square root of x squared, then we get x. And if we take the square root of a positive square root 16, then we get positive 4. And when we type negative square root 16 into the calculator, it will give you an answer of negative 4. So that's really easy. If we look at example 3, then we do exactly the same. We've got a perfect square on the left-hand side. So to remove the square, we will take the square root on the left. We will also take the square root on the right-hand side with a plus and a minus in front. So by taking the square root of the square, on the left remains x minus 5. On the right-hand side remains the positive square root of 3, or we have x minus 5 with the negative square root of 3. Okay, and then we're going to Goro's o'o, take the 5 over, take the 5 over, and when you put this into your calculator, your answer will be x equals 6.73, or it will be 3.27. So the aim here, people, is to get x into a perfect square so that we can take the square root. So when we then look at example 26, at example 26 in your textbook, then this looks slightly differently, and it is not yet a square. So I did this here. You are given x squared minus 6x minus 4 equals 0. So we want the left-hand side to become a perfect square, and it is not. So we have to make it a perfect square. So how do we do that? Firstly, you move your number value to the right. Please don't forget that this is a quadratic equation where we have the standard formula ax squared plus or minus bx plus or minus c. So there's my x squared, there's my x, and there's my number value. So you must get that into this format first. Then you move the number value to the right. So that is just simply doing Goro is o. Okay, and we now want to make the left-hand side a perfect square. And now comes in the new, very important rule. To make that the perfect square, you must add b over 2 squared. Okay, and if we add b over 2 squared to the left-hand side, then remember the rule, be fair counts. So we must do the same to the right-hand side. So rewrite your left-hand side, x squared minus 6x, and your right-hand side, which is 4. And now we're going to take the value of b, which is going along with the x. So that is, plus, we add, we take the negative 6, that's the value of b, over 2, and we square it. All right, and then be fair, add the value of b, which is negative 6, over 2 squared. All right, so that is the principle in making the left-hand side a perfect square by adding b over 2 squared. And that we do to both sides of the equal sign. Now, if you calculate negative 6 over 2 squared, then your answer will be negative 3. And that gives me a very simple principle. The square root of x is x. The square root of negative 3 squared, the square root of negative 6 over 2 squared is negative 3. Okay, and those in brackets squared make up this. So really, people, it is the opposite of factorization, okay? Or actually the quadratic equation factorization. Okay, and then on the right hand side, if you calculate this out, then this gives you 4 plus 9. Okay, I think I must repeat this step. This is now a quadratic equation. If you calculate negative 6 over 2, which is negative 3, and you square that, then it gives you a value of positive 9. Now, to make this trinomial, factorize this trinomial, you then take the square root of the 9 as well as the square root of the x. That answer goes as first term. This answer goes as second term, and it gives you a negative 3. So if you look at the left-hand side now, people, we've got a perfect square. All right, and now counts the principle. We're going to use the square root, and we're going to be fair, as I have explained in the introductory video. If you haven't watched it, please first watch it so that you can understand this. So when I take the square root of x minus 3 squared, then it gives me x minus 3. And then be fair, I must take the square root on the right hand side as well, which gives me the square root of 13. Now remember, because we are taking the square root, we must have a plus and a minus in front. So it gives me x minus 3 equals the positive square root of 13, or it gives me x minus 3 equals the negative square root of 13. Okay, and now we want to find x. Remember, we want to find the value of x, which means I must take over the negative 3. It becomes positive 3. At the same, this one I do the same. I add positive 3. So when I now put into my calculator a square root of 13 plus 3, then it gives me a value of 6.61. And on the left hand side, I've got x left over. I've taken this one. On the left hand side, I've got x left over. Now I put into my calculator negative square root of 13 plus 3, and that gives me a value of negative 0.61. So this seems to be really complicated, but what you must just remember is that you add the value of b over 2 squared, and that you do to both sides. That's why we call it be fair. And once you have done that, you can take the square root of the first term to make it the first term in the bracket. Take the square root over the third term. In this case, it will always be the b over 2 squared, okay, which then gives you the second term of this bracket, and that you must just simply square. Then be fair on both sides. Take the square root, and once you've got that, you will solve for x. This is a linear equation, so you're just simply going to use koro is o.